In this video I'm going to explain how to solve a mixed circuit. We will use this mixed circuit as an example. We can see that it is a very simple kind of mixed circuit, but it will be good for starting with this kind of problems. So since it is a mixed circuit, we cannot apply directly any of the formulas of the series and parallel circuit. So the first step will be to simplify this circuit by creating an equivalent circuit in which we are going to make the equivalent resistance for these two. Since these two are only in series, we cannot make the equivalent resistance for resistance 1 and any of the other, since that will already be a mixed circuit, but these two resistances are only in series, so we can make an equivalent resistance, and the result should be like this. A circuit like this one, we can see that this is a parallel circuit, so we can apply the formulas, but first we must find the value of this equivalent resistance. I call it resistance A. So how do I find the value of resistance A? Well, since resistance A is the equivalent to two resistance in series, I can just apply the formulas of the series resistance, so series circuit, but only for resistance A and its equivalent resistance. So you see, these are the same formulas of the series circuit, but just for resistance A and resistance 2 and 3. So with this we can find the value of resistance A, which will be 50 plus 25 equal to 75. And now that we have the resistance A, we can apply the formulas for parallel circuits, since this equivalent circuit is parallel, and we will use that formulas to find the total resistance. So the total resistance, we will calculate it with resistance 1 and resistance A that appear here. We apply the formulas for the parallel circuit, which is the first to find to sum up all the inverse, which is equal to 5 divided 150, and then again do the inverse, and we will have that it is the total resistance is equal to 30 ohms. And after finding the total resistance, the next step will be to find the total intensity. So since we have total resistance and total voltage, we can just apply the Ohm's law to find the total intensity. That we can see it is 3 volts divided by 30 ohms equal to 0.1 amperes. So up to this point we will have total resistance and total intensity. Now we will have to find the partial intensities and voltage. This part will be a bit more difficult, but we will solve it step by step. So first of all, since in the resistance 1 is the same in the original circuit as in the equivalent circuit, I'm going to just apply the formulas for parallel circuit, the same formulas that I have here, this one. With that formula I will know that the voltage 1 will be equal to the total voltage, which is 3 volts, and then I apply Ohm's law to find the intensity 1. Intensity 1 equal to voltage 1 divided by resistance 1, which is 3 divided by 50 equal to 0.06 amperes. Also always remember that partial voltage or partial intensities can never be higher than the total voltage or total intensity. And sometimes, like this one, it could be the same, but never higher. That's not what happened with resistance. As we can see, some of the resistance are higher than the total resistance. And now, how can we continue with voltage 2 and voltage 3, intensity 2 and intensity 3, since those resistance are not in the equivalent circuit? Well, first we are going to find intensity A. That's because, as we have here the formulas for series circuit, but only referring to resistance A. So if since in series circuit all the intensities are the same, if we find intensity A, we will have intensity 2 and 3. So I'm going to find intensity A in two different ways. One will be to apply Ohm's law, since we have the value of voltage A, which is equal to the total, and the value of resistance A, we can just apply the Ohm's law and it will be 0.04 amperes. The other way is that since we already have intensity A and total intensity, if we make total intensity minus intensity 1, this is a mistake, this is intensity 1, is equal to 0.1 minus 0.06 equal to 0.04 amperes. We see that the answer is the same in both ways, so that helps us to make sure that we haven't made any mistakes. If the answer were different, we will have to check the problems to check all the things we have calculated previously, because there could be a mistake in that part. But since both are the same, it's all correct. And now that we have intensity A, we also have intensity 2 and 3. So we can just apply the Ohm's law to find voltage 2 and voltage 3. So the formula, the Ohm's law for voltage is intensity multiplied by resistance, so intensity 2 multiplied by resistance 2 equal to 0.04 multiplied by 50, which is 2 volts, and the same with the voltage 3. Intensity 3 multiplied by resistance 3 is equal to 1 volt, and that will be the final answer. If we want to make sure, we can try to sum up voltage 2 plus voltage 3 and check if it is the same as voltage A, as we have in this formula. So if we sum up 2 plus 1 is equal to 3 volts, and as we know, as we saw previously, voltage A is equal to total voltage, which is 3 volts, so it will be correct. So up to this point, the end of this exercise.